Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. So here we are going to use two methods to address the problem. So the methods, the first one will be a direct check. This is due to the problem size, which is not very large. And the second one will be backtracking, right? So the backtracking is also basically construct also possibilities, right? Possibilities. So here I'm not going to read through the problem statement, but the one point I want you to notice is that we need to return a sorted array of the unique integers, right? So with that said, now let's look at the problem, look at how we solve it. So the first version will be direct check. Here we are going to use a triple for loop because the length is bounded above by 100. So if you use a triple for loop, so the time complexity is roughly at a scale 10 to the power 6, right? So still should be able to pass. So first I'm going to get the length. So here let me use this digit as a, just for convenience. So then we are going to initialize a result to hold the thing. In order to deduplication, I'm going to use a set, right? And then for I in range n, so for j in range n, and for k in range n. So we need those to be different. So therefore, the criterion will be length of this set I, j, k equals 3. So then we check the criterion. So if ai, so it's not 0, so we're going to use this as the hundreds. And the last one, ak modulo 2 should be 0, right? Then we're going to add this one. So add this 100 times ai plus 10 times aj plus ak to the result. Then because the result as a set is not ordered, so we are going to return sorted result. So this actually gives the tuple, right, I guess. So but if you want, you can translate it into a list, but this will still pass the requirement. Let me first run it. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases, but relatively slow, I would say. So now let's look at the second one. So the second one, I'm going to use backtracking. So here, I'm going to change this one to be version v1. So now for this one, we are going to use backtracking. So here, I'm going to use a dictionary to help with dictionary to help me do the job. So here, because the digits contains all the digits, right? So from 0 to 9, I'm going to make a table to count it. So how to do that? So we can see frequency. So basically I have 0 times so 10, right? So also I want to have a result to hold all the different things. Here actually we can also use a set, right? So now first let's iterate over this digits. So for d in a, right? So the frequency of this digit will be incremented by 1, right? Next we are going to do the backtracking. So explicitly construct all the possibilities. So for a in range 1 to 10. So this is for constructing the hundreds digits, right? So if frequency of this a is 0, right? So we just need to continue. So otherwise, so we are going to use one of these digits. So its frequency is decremented by 1. This is the construction of the hundreds. So we also need to consider the tens. So for b in range 10. So here b can be 0, right? So then if frequency of b is 0, continue, right? Otherwise, so we're going to decrement b by 1. And then we're going to consider the last digit. So basically for c in this two, 0, 5, 4, 6, 8, right? Those 5 numbers. So because we require the digits to be final number to be even, so we just need to require the last digit to be one of those 5 integers. So if frequency of this c is greater than 0, right? So we can do add. So 10 to the power 100 times a plus 10 times b plus c, right? So this is dealing with this one. So afterwards, so for c, right? So we need to recover this b, increment this b by 1. And similarly, so we need to also recover this a. So if you look at the pattern, so here we use a to try. If does not give a good result or give result, so we also need to recover this a. This is the backtracking. Similarly here, b, frequency b minus 1 and the frequency b plus 1. You might wonder, I didn't use increment c or decrement c because here I didn't alter the frequency. But this is one way. I'll make a comment further on this, right? So once we have this, so what do we do? So here I guess we need to do the correct indentation, right? So now we can return sorted this result. Let me run it. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it's decently fast. So this one. So now let me comment on this format, right? So you can still write as the previous one. Let me copy this one. So going to change this one to be version v2. So here actually you can do the same thing. If frequency of c is 0, continue. Otherwise, frequency of c is decremented by 1. And then in the result, you still add this number. But after you add this, you need to do frequency c added back. So this will be more symmetric, right? You have a minus the 1 and a plus 1. You have b, so minus 1 plus 1. You have c minus 1 and plus 1. Let me run it to do a test. So I have changed this one to be version v2. We are checking this one. So run it and submit. Yeah, it passes all the cases. So with that done, I guess we are finishing the coding part. Let me make a comment. So here, this problem is an easy one, which you can solve it by brute force essentially. But it's good to use this kind of examples to practice some algorithms or methods. For example, here we are practicing backtracking. So this would be actually very beneficial. With that said, I guess that's it for the current video. You are welcome to follow up in our channel for more practices. Thank you.